Hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own Mask Coder this side. So we are going to start learning stacks from this playlist, and as you can see that I am fully pumped up for this. I guarantee you that this playlist is gonna be the best playlist present on the YouTube. And how I'm able to guarantee it? Because this playlist will contain around 50 to 60 questions on the basis of stacks only, and whenever you practice these much questions on a particular data structure, you tend to master it, right? So if you are going to follow this playlist from the very beginning to the very end, you are able to identify and knock off any question of the stack data structure, right? Now let us start learning it. Let us not waste time about the playlist, etc. Let us just start learning it, right? So in this video we are going to teach about introduction to stacks, that what are stacks, why is there a need of stacks, right? And after that we will be learning about the implementation in the VS Code of the stacks, right? And then some basic features like what are the operations on the stack, right? What you can do, what does stack actually provide you? Okay, so stack. So when I was learning stack from my teacher, the teacher told me something like this. Suppose there is a sink, in the kitchen. There is a sink in the kitchen. Now you kept your plate here. You had your dinner, you kept your plate there. Okay, you kept your plate there in the sink. After that, you waked up, you had the breakfast, etc. You kept another plate. After that, lunch, another plate. Believe me, suppose you don't wash the plates. So what will happen? Something like this will occur. Like this is plate 1, this is plate 2, this is plate 3, this is plate 4, this is plate 5. Which was the one you put the earliest? Which was the one you put the earliest? Your answer will be that this is the one I put the earliest. Now, when you start washing them, what will happen? Which plate will you take at the first? Which plate will you take at the first? It is but natural that you will take this plate to be first to be washed off. This plate to be first to be washed off. You will wash it, keep it here. 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 So you can see the 1, 2, 3, 4, 5 order has actually become 1, 2, 3, 4, 5. The reverse. The reverse. The one which was put in the earliest. The one which was input. The earliest is the one that is output the last. Output the last. And the one which was put in the last manner, input the last, is actually getting output in the first traversal only. So output the first, right? So you can say last input first output, or you can say first input last output also, right? But this is more generally said. So first output, which can be said as LIFO, short for last in first out. LIFO, last in first out. And that is whole stack. This is the only thing of stack. Stack is something which you put in last, you take it at first. You take it at first, last in first out. If you know this much about the stacks, believe me, you have studied all the stacks. Only stack is this much. Only things in the stack is you have to develop some patterns, right? You have to see some patterns, how to solve them. For that, we will practice many more questions, right? We will practice many more questions. Now, how to implement stacks? So C++ has a standard library which we all know about, which is known as STL, right? It contains a stack data structure. But we will be telling about how to implement stacks on our own, and then we will do something like this. Okay. Now, when I was learning about stacks, my teacher told me to implement stacks using a fixed size array, not a vector. Believe me, not a vector, but an array, And when I said array, what do he mean? It meant that stack can have a maximum size, Obviously, if I'm using an array, I have to define some size. Of this array, and that means stack can also hold only that much values, right? Stack can hold only that much value, right? So that means if I take the size of the array to be 5, right? 5, 4, 3, 2, 1, right? And I said that this is a stack. What do I mean by this is a stack? That means 5, 4, 3, 2, 1. If you will represent your stack always in top to down fashion, you will never get mistaken in the case of stack, right? But this is my array. This array has to represent my stack. how will I implement it? How will I implement it? So first thing I learned about is last in, first out. Last in, first out. Okay. Now, how will I use this information to implement the stack using an array? Implement stack using an array. Before implementing, we will have to learn what do we have to implement, right? You should have asked me the question, what do we have to implement? What do we have to implement? What do we have to implement? Okay, let us see what do we have to implement. Stack has some basic operations. First operation is push. That means if you have a if you have a stack of plates, push another plate. That is push another plate. Okay, so push means adding new element into the stack. Adding new element into the stack. Second operation is removing the element, which is known as pop, So that means this plate has to be removed. That means this plate is popped out. So remove the element. Remove the element. Now, when you see that, suppose this is a closed sink, this is a very narrow sink. You put plate 1 here, plate 2, plate 3, plate 4, plate 5, plate 6. Suppose this is plate 1, 2, 3, 4, 5, 6. You take a peek from here. Suppose this is your eye, and you take a peek from here, and you will be able to see only sixth plate. Only sixth plate. You will be able to see on the fifth plate only when you remove sixth plate. Only when you remove sixth plate. So from top view, you are only able to see the sixth plate, right? So the stack also has the functionality of third functionality of top, which is tell me the topmost element. The topmost element. What is the topmost element? That is the element. If I will apply the pop operation, then topmost element will get popped out. Topmost element will get popped out. In that case, 5, 4, 3. If this is my stack and I see the top, 3 is my top. 3 is my top. These are the few operations of push, pop, top. Other than that, there are two operations as well. What are the two operations? The fourth operation is empty. Tells you whether the stack is empty or not and is full. This is my fifth operation, is full. These are the only operation of stack. So you can just imagine that how easy the stack is gonna be. But believe me, there are some questions which will use stack and you will not be able to configure whether it is using stack. See, stack problems are difficult. Why? Stack problems are generally difficult because you are not able to configure whether I have to use a stack here or not. Stack problems only get to you after practicing stack so much that this question can be done by stack, I guess, can be done by stack. Otherwise, they will not no, you will not be able to click that stack is a probable route to go, right? So stack only needs to be visualized that I have to apply stack. Once you have reached to the conclusion that I have to apply stack, you will be able to solve the question, right? You will be able to solve the question. Okay, so push, pop, top, is empty, is full. How will you do it? How will you do it? So I have an array. Suppose my array is initially empty and I initialize an array. Let's take the length of the array as n. Let's take the length of an array as n. I want to configure push, pop, top, is empty, and is full. How will I do it? How will I do it? Easy, easy. Now I know that I have to just keep account of the last one. I just have to keep account of the last one because I have to return that only. So what will I do? I will keep a pointer here. Let us say index pointer. This size is given to me as n. Suppose a person calls push 5. Suppose a person calls push 5. So what will I do? Suppose this is my array. What will I do? ARR of index is equals to the value, right? And then index plus plus. This is the implementation of push. So what will happen? It will put 5 here and move index here. What is the value for pop? What is the implementation for pop? Simple. My index is here. I just have to return the previous element, that is index minus minus, and then like index minus minus, that is index will no longer be here, index will be here. And if you said push 7 now, so 5 will be replaced by 7, so it is actually getting implemented, right? It is actually getting implemented because 5 is replaced by 7, so 5 doesn't have an essence here. So pop is only index minus minus. What is top? I have to return something now because I have to return a value. So I don't have to shift my index here. I just have to peek it. I just have to see the previous value. So return ARR of index minus 1. This is a top operation. What is empty? What is empty? So if my index is at the 0th position, if my index is at the 0th position, return true. So return index equals to 0. Index equals to 0. And similarly, what is full? So if index is out of the bounds, index is at n because the size is n, so index should be at n because that means that value has been filled. So return index equals to n. Index equals to n. Now the base cases means now the edge cases, sorry. So what I'm saying is, suppose I try to push. If my index is already here and I try to push value, let's suppose I try to push 10. Is it possible? If the stack is already full, how can I push something into it? It is not possible to push something into it. So what will I do? I will say, whenever I am set to push, what will I say? If is full is not true, only then do so. Okay. Similarly for the pop, if the stack is already empty, what will you do? You cannot remove anything. So if is empty is not true, that is the stack has some elements, only then do the pop operation. Same for the top operation, if is empty, otherwise they will give the segmentation fault, right? Some simple things you have to notice. I am sure that DSA is not that much difficult for you right now. Okay, so this is the basic implementation of push, pop, top, is empty, is full, right? For a fixed size array, obviously for a fixed size array. Moving towards, what if I use a vector? The things will be very much easier. What can I do? If I have a vector, so instead of pushing, I will just say vector, like suppose it is v, so v dot push back, etc. If I have to pop, v dot pop back. If I have to see the top, v dot back. If I have to see the empty, v dot size equals to 0. If I have to see the full, now that is not possible because vector doesn't have a fixed size. But if you will say that vector has 5 elements or not, you can see that operation, right? V dot size equals to 5 or not, etc. Okay, this is something like for vector. This is for the vector implementation. You can see the video is going very fast because I don't have anything to teach here. The main things are the questions you have to practice, right? Okay, now moving on. STL. I talked about STL. That standard template library has something as known as stack data structure, already defined. So that is the most easiest data structure you are going to see. Stack data structure is defined something like this. Suppose I want to create a stack of integers. So I will just say it is small s stack angular brackets. The type of data structure I want to keep, I can keep a pair of integer, I can keep a vector, I can keep a string, etc. Anything I want, any data type I want, right? Suppose I want to create an int st. You can create any name. I generally name st as stack. Okay, this will create your stack. And you don't have to implement pop, top, empty, is full, etc. for this stack, right? STL has already defined that for you, right? The operations are same. st.push for pushing the values, anything here. st.pop for popping out the values. st.top for what do we say? A top value of the element, and then st.size to get the number of elements in the stack right now. This is this STL stack, right? This is the STL stack. So I don't guess there is need for any implementation in any language because most of the time you are going to use this only, right? Most of the time, not all of the time, right? You will not have to implement your stack from scratch in any problem unless and until interviewer says. And if interviewer says this is your answer, right? This is your answer, best answer possible, right? Okay, so this is about the implementation of stack. Now, so let's end the video here. This was just an introductory video, just to give an idea about what a stack is, etc. etc. From the very next video, we will start doing the questions as usual, right? Because every data structure has nothing to be learned. Believe me, you will only learn the things when you will practice the question. That has worked for me, and that will work for you as well. This is all about stack. Just watch it again if you want to watch. Only 4 operations. st.push, pop, top, right? You just need to understand that stack works something like this: 1 2 3 4. Last in is gonna be first out. right? Anything can be done, anything to be input will be put on the top of it, and anything to be take out will be the top element only. So st.push will push the element into the stack, st.pop will take the element out, st.top will give you the glimpse of the top element, that what is present on the top of the stack, and st.size will give me the number of elements. Suppose 5 4 3 2 1. If I call st.size here, it will return me 5. It will return me 5. Okay. From the very next video, we will be starting doing the stack question, and I will try to upload as many questions daily on the stack topic so as to finish the topic as soon as possible. Obviously, we will be doing the practice question as well. Okay. So thank you for watching, and we'll meet in the next video. And please make sure to subscribe to the channel and hit the like button as much as possible. Thank you. Have a nice day.